Hi, my name is Bryan Wallace, but you can call me Kent. I'm an instructor here at Fisk University in Nashville, Tennessee. Officially, my title is Director of Physics Laboratories and Coordinator of Rocketry. So, what's this series about? Well, I was looking at students over the course of 12 years, almost 13 now. And I've seen students that are incredibly gifted, and I've seen some that had challenges with solving physics problems. And I wanted to make it accessible for everybody in the classroom. So I noticed certain, problems that students might have and wanted to address those. So who is this video for? Well, if you're working on your PhD in nuclear physics, this video is probably a little simplistic for you. But if you're in high school physics or college physics, university physics, or getting ready to take the MCAT to pursue your career in medical school, then this video is for you. I want to talk to you about strategies to solve physics problems. I'm not going to show you how to just solve a physics problem. I want to teach you strategies that you can apply to any physics problem so that you can get the correct solution. Before we get started with the nuts and bolts of solving physics problems, I want to talk to you about some experiences that I've had in the classroom. For students that tended to not be able to solve physics problems, one of the biggest problems that they had was their perception. They might see a concept or look at a problem and they're like, oh, that was too easy. And they overcomplicate things and get the wrong answer. Your perception is one of the biggest things that can affect you solving a physics problem. You have to believe that you actually know what you're doing. Also, you have to believe that you're smart enough to solve these problems. And I got news for you. Let's get that word smart out of our mind. Everybody's smart about something. I mean, think about this. If you had to study 1 hour for a test and got an A, and I had to study for a week and take the same test and got an A, when we look at your grades in the grade book, who's smarter? We're both thought of as smart. Smart is a very relative term. Don't be so concerned with how long it takes. Just know that you can do it. So let's start to look at the way you should start looking at physics and math in general. I used to be bad at math too. And one day I heard a quote by Galileo Galilei, and it just changed everything. That quote was, "Mathematics is the language in which God has written the universe." And then it clicked. Mathematics is a language. I could talk to you just like this, or I could say to you, "Ich weiß nicht, was soll es bedeuten, dass ich so traurig bin. Ein Märchen aus alten Zeiten, das kommt mir nicht aus die Lehn. Die Luft ist kühl und es dunkelt und ruhig fließt rein. Der Gipfel des Berges funkelt Abendsonnenschein." Now, the only difference between me speaking to you in English und sprechen auf Deutsch is which nouns, verbs, predicates I choose to use for you to understand what I'm saying. Math is exactly the same way. Let's look at this equation really fast. X equals x naught plus v naught t plus 1/2 at squared. This is one of the equations known as the kinematic equations. Now, some of you are looking at this equation and just seeing a bunch of symbols. But in actuality, you can read this like a sentence. But in order to do that, you have to realize where are the words. Well, the symbols or variables, those are nouns. The operations like adding, subtracting, dividing, those are verbs. And the order of operations, that's grammar. So I could look at this and say x equals x naught plus v naught t plus 1/2 at squared, or I could read it like a sentence. The final position of an object is equal to that object's initial position plus its initial velocity times time plus 1/2 that object's acceleration times the time it travels squared. Any sentence that you say can be abbreviated. I know where something will be if I know where it was, if it was moving, and if so, how was it moving and for how long? Symbols, X, V, A, T, those are nouns. Your multiplication, adding, subtracting, dividing, those are verbs. So now, I want you to start to think about looking at equations. Learn each symbol. Learn that X equals final position. Learn that X naught is the initial position. Learn that V naught is the initial velocity. Now that you know what the symbols represent, you have a better chance of understanding what the equation means.